up, guys? What's up for the 15th video here for the CCENT ICND 1 certification 100-105 lecture and lesson 15 broadcast domains. So I know it's getting crazy, guys, right about now, and that is fine. We're going to see a lot more going on. Now, I've been doing a lot of virtual labs, Packet Tracer, GNS3. We're going to come away from that. I know I was like, oh, buy a lab, physical. I think that is still the best route to go. But right now, we're just doing that because visually I can show these things better, like collision domains, broadcast domains. So we will eventually get to the good stuff of that rack over there. It's coming, so don't worry. It's on its way. We'll be over there and hooked up. I like to hook up physically. I want to show you guys physically what it looks like, so there is no shenanigans, and show you guys how it actually connects once it gets to that part. So, without further ado, let's get to talking about broadcast domains. So, let's switch over monitors. There we go. I still need a better mic. Every time I go back and look at these videos, the mic quality could be a heck of a lot better. So, alright guys, this is something you will need to know for your ICND 1. You will see some form of it with it and collision domains. Now, what I've got here is some IP addresses. Everything is up. We've got a 3950 switch in the middle here, and then another 3950 switch on the right side in the middle over here with the IP addresses around. And then we have a router in the middle. Remember, layer 2 devices. The cables are layer 1. Remember, the ports on the device is considered layer 1 also. And the devices themselves, layer 2, handles layer 2, router, layer 3. But remember, the ports is considered layer 1 to a certain extent. So remember, by default, if you're replicating something like this and you're using Packet Tracer, you need to enable your ports on the router. I've already done that for you, and I've done nothing crazy to this point. All I've put in is around each of these PCs is the default gateway, which goes to here. And for this side, their default gateway goes to here, to the closest port on the router facing towards the network. It's a quick way to that. And then if I go down here to fast Ethernet 0, you can see I statically assigned an IP address and a subnet mask. We'll talk about setting up a DHCP via router eventually. But for this one, we're just looking at broadcast domains. So first, let's talk about what is a broadcast domain, or how do we determine how many broadcast domains. So you might have a question, for example, on your ICND 1 or some form that says, in this network that you see, how many collision domains and how many broadcast domains are there? Now you might have a question to that extent, or you're going to have to have that knowledge to answer questions on your ICND 1 or understand it. So, we're only talking about broadcast. If you ain't sure how many collision domains is in here, you need to go back and watch the collision domain video, which was lecture 14, guys. So, without further ado, let's go. And then I mentioned one of the videos I was going to tell you guys where to catch me. I do network tutoring for stuff like this to help anyone who's willing or wants hands-on, like straight person-to-person for your certification. I'd be more than happy to help somebody, as it is, better than actual videos, because I don't know your weak points. I don't know what you misunderstand, and I might not be explaining it right to everybody. Somebody might understand it, but somebody else might not understand the way I explain it, and if I explain it a totally different way, it makes more sense. I find that a lot with students that I've taught, so I know that it is possible. But I try to teach it as an open range so everybody understands it. So, what is a broadcast domain? How do we determine how many broadcast domains we have? So, a broadcast domain is simply divided by a layer 3 device. These are layer 2 switches. They're not layer 3, but we have a layer 3 router, so it divides our broadcast domain. Now, when they say a broadcast domain, you need to understand that a broadcast domain, or the easiest way that I look at it, is you're flooding all F's through your MAC address. Where all does it go? and your MAC address changes at the router, it stops. So basically you don't carry the same frame, and the router will change the layer 2 frame. So, but we're going to look at that. So in a broadcast, how does that work? So technically here we have two broadcast domains. We have here to the router. Remember, you got to include the router's port. And here, that is the broadcast domains. So there's two broadcast domains in this topology shown. Collision domains, we have 1, we have 2, we have 3, we have 4, we have 5, and we have 6 for the right side. And then I'm not going to go with the left side. You can watch the collision domain video. That is not the total in this topology, but from the right to the router to the right, that is how many that we have. And then it would be plus this side for the entire amount. So okay, going back towards what I was talking about, we're going to go over here to simulation mode. So what I'm going to do, I'm going to ping 10.1.2.1 over to 10.1.1.1. Notice that they're both a 255.255.255.0 subnet mask, a /24. So let's go to a simulation here. So we're going to ping from router 2. We're going to assume that no MAC address tables, no MAC addresses, or nothing's been learned here by the switch. So let's go to a command prompt. We're going to ping 10.1.1. What did we say? 1. Up 1, and we're going to hit enter. Notice we're already sending out an ARP. So let's take a look. Here's the packet. This is what I love about Packet Tracer. We're going to be able to watch how this works. So it goes down to here. Remember ARP, we're going to flood out of all frames. There's the flood. Looking for the IP address. Notice all of them gets canceled. Goes back to the router. The router feeds it to the PC. Notice what the router did here. It's going to respond back. And it's going to go back to here. And then the router cancels it and passes it through. So it doesn't rebroadcast. And notice now that it's not here, it'll flood through every port because he changed the broadcast. Now it would still broadcast through, but the router controls the broadcast. If you paid attention, he divided how the broadcast actually worked. But the switch still didn't know where the MAC address was. So notice, DTP, I ain't worried about that. STP, I'm not worried about STP. So let's do another ping. We should have a reply. Is it going to show? Showing the STPs. And notice that the STP will be canceled by the router. All these devices don't understand how to do STP or do it. Another DTP is being sent, and I think the pings are probably done. So what happens if I ping from here to 10.1.2.1? We're going to ping it up, or pings rather yet, 10.1.2.1. Now we're going to follow this purple packet. Ignore the other stuff going on for now. Notice it goes to the switch. Now will it flood all ports? No, it remembers the path. Remember we sent a ping from here. Now notice the router's going to take this and it's going to forward the packet out of the port and from there. But if we go back and we take a look here, notice now it's returning the information here. And we look here at the end layers as the came in from 10.1.1.1. Notice the destination is 10.1.2.1. Notice the layer 2 header here. Look at the MAC addresses. But whenever he sends it out, notice the change here by the layer 2. The layer 1 stays the same, but the layer 2 actually changes. it changes. So let's stop this for a minute. So the layer 2, or the MAC address, actually changes. And the router, if we go into here, if we can get a visual. I want to show that. Show interface giga 0. What is that one? 1, I believe. 0, 1. Yep. 1. Let's go back to packet tracer here and bring back up router 0. Looking for the MAC address. Notice the MAC address right here. And notice that the MAC address is replaced by the router's MAC address as it sends it over to PC1 over here. So this is why I like Packet Tracer. It's really good at demonstrating how a packet is carried across the network. Now let's go back up to where there was an ARP message, because I want you to see these. I want to see it go to the router. All right, so when it goes to the router, notice it's sending an ARP. Notice that the destination IP address is 10.1.1.254 on the ARP. So if we go back over here to PC, what is this? It says PC7. Let's find the switch actually. That is the switch. So the switch here, if we look, is still going to the default gateway. And let's see, let's go on up here. Let's go a little bit further up. So we got an ICND header here. PC13. Trying to find you a better. Let's go up here. Okay. Here we go. Here's what I'm looking for. Alright. Look at the ARP here. So it's broadcasting and looking for 10.1.2.254. Remember, we're pinging 10.1.1.1. So what it is, it's looking for 10.1.1.1. But your network's smart enough that actually the way we got this programmed, it does not know. But what I want you to focus on here is the MAC address. This is going to flood through every MAC address port. And if we have more switches, it will continue to flood through ports, as you've seen in the collision domain, or the ARP video actually. If I had a switch at this PC, it would just forward it out of every port. Where it stops and what doesn't forward it out of every port is your router. Your router understands where a network is and knows which port to send it out of, and it divides up the broadcast. Without routers, we would definitely have basically a flood of broadcast addresses, and a router helps divide that up within a network. So if we look at the header here, you can see the destination. Here is a broadcast address, all F's. But notice that the target IP address doesn't change. Now, once it gets over here, let's say we go back over here to the router. Notice layer 3, layer 2 is not made. That's why ARP is there. It doesn't know how to layer to layer 2 yet. And let's see if I can find the bound. I'm looking for the packet when it is bounded to the router. And let's see. Okay, here's the router. Now notice the router gets the broadcast, and then when it goes out from here, it's going to, oh, actually it doesn't show it there. Go on ports, let's see. See if I can find the switch here. There we go. It's okay. If we look here, this is when it hits the switch over here looking for PC1. Notice that we've given out an ARP. And the destination, or the source IP address, is not 10.1.2.1. So notice that. And you'll learn more about this as it goes on. Actually, it is the router. So the router has changed the destination address to its IP address. and then the source or the source IP address, but the destined IP address is 10.1.1.1. Now what happens if we go down here and we get a reply from, I think that is PC maybe 7. So once we get our reply from PC 7 here, it's going down, we get it right here. Let's look at its in layer. So its destination address. Notice now the source address is 10.1.1.1. The destination is 10.1.1.254. Now notice the MAC addresses stay the same, in and then going out. Stays the same. Or, yeah, stays the same. Notice here, stays the same. Here the source MAC address stays the same. But once it traverses past the layer, which it doesn't show here, and then show the full effect of it, it will then, which the routers learn, but basically once it comes back across the router, the source MAC address will become the router's MAC address for this side, so it changes the packet, and the source IP address comes from the router also, and then it will forward it to the PC. So it divides broadcast addresses. So let's watch this again. We're going to watch this all the way up from 1. I don't want to do the ICMP, so let's go back, going all the way back to the top. There we go. So okay, now we're going to watch this. Remember, PC 10.1.2.1 is trying to get to 10.1.1.1. These don't have any kind of information at all, so watch this. We're going to actually reset the simulation. And I did not want that. I don't want no STP. And let's send a ping again to 10.1.1.1. Notice we got it now registering and up. And now let's watch slow motion how it goes. It goes to the switch. It's going to flood all ports but the port that it came in on. Well, actually this time it doesn't. It still remembers the MAC address table. So now it actually, the switch, or what happened here is that the MAC address table is learned by the switch. I thought it would actually reset it with this, but it did not. But if we power cycle the devices again, so let's power cycle. We're going to power cycle the devices. Let's save our configuration though on this so it doesn't go back down. So we saved the configuration on there. So we're going to power cycle all the devices. So we're going to let them come back up. Once these ambers go to green, we will go back over to simulation and we will replicate the ping again. So I want you guys to see how broadcast domains work. Understand that the word broadcast, it's like sending a broadcast, so I feel the best way is understanding it as a broadcast. Okay, now we're good to go. So let's go ahead. We'll do it from the opposite side this time. We're going to do it from 10.1.1.1. Oh, I did not mean to do terminal. We're going to do 10.1.1.1 to 10.2.2 or 10. Alright, so ping 10.1.2.1. And now we've generated the packet. Now let's watch. Remember, no MAC address tables are learned at this point. We should see it go out of all ports over here. See how when it goes out of all ports except the port that it came from. You will need to know that also and memorize that. Now notice the router is going to send it back. So what we know here is that if you remember a switch, if I had a lot of switches, they just kept forwarding it. They did not never reply back and stop it. Notice that the router actually stops it and says, hey, I know where that is, and I'm going to, you need to bring it, you need to give that packet to me. That's basically what it says. Hey, I know where it is, but you need to give that packet to me, and I'll take care of it for you. And the term router is routing the packet for you. So that's why we get the send back. It's saying, hey, I know where this is, give it to me. And if it gets a reply on the switch, of course, it's not going to go to the router. It would go versus the switch on the MAC address table. And notice that it goes right back. Now the switch knows where PC 7 or this PC is. Now notice that now we went from the ICMP packet here, say layer 2, it's telling it basically, let's go back a little bit more. Let's go up to where the router is. So the router is saying, hey, send it to me, I'm the source. Remember that a PC, only if it sees it and it sees its address, it will reply. Notice that the router, it wasn't the router's address, but it replied, and the PC communicated with it. So it replied back and gave the PC more information, saying, hey, send it to me. So, comes in on the router, destination 10.1.1.1, we go back up, let's go to, this is where it splitted everything. Let's go back up to where it was out layer, and let's go back up even more. So here we go. It's the ARP. This is originally how it looked. Remember, it was a broadcast. Look, it sends it here. The only reason now it's sending it here is we got a default gateway though. But if it was from there, so it's going to send it to the default gateway, and it's going to come back and say, hey, send it to me. I'll handle this packet. But notice that we're on a, I want you to notice that it's all F's until it gets to the router and it goes out of the router. And then guess what? It's not F's anymore. It's not a broadcast. He stopped the broadcast. He stopped the broadcast and he changed it to his MAC address. Hence, broadcast domain. Alright, so let's watch the rest of this. Now it's going to come to the router. Notice the router is going to grab this. It's going to say, hey, I'm going to do away. I'm going to change. Now the reason it shows an X is that the router takes information from that. It takes out the destination, replaces the destination, and sends it. And basically, a router can edit a packet source and destination. And basically recreate the packet by stripping the header or some of the information off of the packet. I won't go into too much detail because for the CCENT you will not really have to know a lot about that. Like I said, I'm going to try to keep it to what you need to know. Notice that it forwards it out of all ports on the switch. It doesn't have the MAC address of this PC yet. And then that packet's going to come back here and it should have a reply. And there it goes. It's going to come back. Notice how quick this actually happens in the timer. This happens very, very quick, guys. It's not even a second yet. Notice the router gets it and it stops it. So let's we're going to stop that. Now let's do a ping from 2.10.1.2. or 1.1. Sorry. Let's ping again, and we're going to show this. We're going to pay attention to this purple packet. Now that's STP. Now this pink one's not the purple. That was STP, which auto-generates by the switch. It's something that switches do. Spanning tree protocol. And you guys will have seen that in the 2 videos ago, talking about a little bit more of the advanced features of the switches. So follow the purple packet. It's now at the switch. Notice it goes to the router. The router is going to recreate that packet. And notice it'll send it right on through, changing the source. So the PC knows to send it to the router, and now the PC has gotten it. And the PC will reply back saying, hey, I've received the packet. We have communication. And then it goes to the router. And then it should shoot back across to PC1. And there we go. And back up it goes. Notice how quick this is happening. It's very, very fast. So let's see if we can do that without the... I'm going to see if I can get that without the delay so you guys can get an idea of how fast that actually is. Okay. So we're going to take off the constant delay. I'm going to ping again here. If it'll let me. We're going to play it. Notice. Goes to the router. Going to go to the switch and then straight to the PC. But remember, when you don't have the main thing I want you to remember, this is based on broadcast address and broadcast domains. What I want you to understand is everywhere that receives the FFF, the hexadecimal all F packet, and doesn't stop it and keeps forwarding it, is considered a part of a broadcast domain. The device that stops it or changes it divides it. So a router will always divide a broadcast domain, hence why we have two broadcast domains. Now let's say that we have switch. Let's grab a switch, and we're going to grab some PCs over here. Packet tracer right quick, and let's get them connected. Don't think I'm gonna have an extra port on this router, but maybe I will. I can't remember. And I will. So I want you to look at this. So now what's happened? How many broadcast domains do I have? So look at this. I want you to look at this and think, how many broadcast domains do you see in this drawing? Alright. Pause the video if you need more time. We have 1. We have 2. We have 3. All 3 of these connect. The broadcast domain is divided by a router or a layer 3 device. So it'll go all the way to this port on the router. It'll go all the way to the port of the router. And once it actually hits the device, it is a separate broadcast domain. So each port on the router is a separate broadcast domain. Now whatever is past it is part of that domain. Now let's get this question a little bit more difficult just for practice, and in the next video we will be looking over this, as this is something important to learn for your ICND 1 for the CCENT certification. So what I'm going to ask in this video before we let go is I want you to look how many collision domains and broadcast domains do you see? So how many collision domains and broadcast domains do you see in this topology? If you need more time, pause the video. So first we're going to look at broadcast domains. How many broadcast domains do we have? Well, we done said this earlier. We got 1, we've got 2, we've got 3. So how many collision domains do we have? Well, first we need to evaluate what devices we have. We know the router divides the broadcast. We have switch, we have a switch, we have a switch. So no hubs. So the collision domains would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. We have 21 collision domains. You will need to know, if you do not know how I got that, you will need to go back to your collision domains and look over these closer before you proceed to lecture in lesson 16, which would be questions to help you guys answer or see if you can answer how many collision domains and how many broadcast domains there are or that you see. You must know this for your ICND 1. It is very beneficial to understand it, and and the questions beyond this is going to get more complicated. So if you cannot understand this one, I recommend you go back to the collision domain video, guys, also. So guys, I hope that video was beneficial to you for the lecture 15 broadcast domains. Guys, if you're interested in catching me, or you need personal help or tutoring in any of these things that you have trouble with, feel free to contact me. You can do comments below, or you can email me. If you email me, it's Strifex, STRIFEX 1986 at gmail.com. And in the headlines, just put need help, or need you to teach me, need you to tutor me, however, so that way it catches my attention and I will talk to you. I go through a website, so everything's legit. It's backed up. First hour guarantee. Basically, if you feel like that I was not good enough the first hour, you will not have to pay anything from there, but it's a set rate. It's mediated between there for honesty purposes for both sides. And it's a very good website. I've used it. I think I've already done 10 to 15 sessions, and so far I've got a 5-star rating. I'd like for it to stay there, but realistically, once it gets up, you're going to have somebody that ain't happy just because they just ain't going to be happy. Or maybe they took something and they maybe didn't get a real good grade, but they really might not have listened fully, and then they're going to take it out on me, and I'll get, from there. But I'm hoping to keep it as high as possible. I go at a really good rate, so just talk to me. It depends on the hours. So until next time, guys, if you enjoyed that video, please subscribe. Let me know. Like the video. You can comment. Do whatever you want to do. If you got any questions about this, please feel free to reply or comment, or you can just message me, whichever. Until next time, guys, see you in lecture and lessons 16. Do you know how many broadcast domains and collision domains are there? Will be your next lesson. See you guys, and peace.